Example 53. If a store has 20 DVD players on a shelf that work perfectly and 3 that are defective, find the probability of randomly selecting 2 defective DVD players when purchasing a pair of DVD players from the store. Okay, so in this problem, they're asking us to find a probability. It says find the probability. The only thing we have to do is figure out what kind of probability they want us to use, right? So find the probability of randomly selecting 2. Aha. So right there, when I see that 2, I know it's multiplication rule of probability. How come? Well, if you're taking 2 items, that's 2 separate events, right? If I go to the shelf and grab one DVD player and put it in my cart and leave the store, that's just one event. But if I go to the shelf twice to get 2 DVD players, that's 2 separate events. And this problem is asking what's the probability that when I do that, they both end up being defective. So we're looking for the probability of 2 defective DVD players. So probability of 2 defective DVD players. Okay, so that's what this problem is asking us to figure out. Now, once I know its multiplication rule, I know this 2 for the 2 events is going to lead to 2 spaces, right? Those 2 spaces is where I'm going to place the probability for the problem. Now, inside those spaces, I have to fill in the appropriate probabilities, but before I can do that, I have to think about what those spaces are in this problem. So what I'm going to do is say, okay, well, what does this first space represent? Well, I would say that's my first DVD player, right? The first one I take. First DVD player. That's the first one I select and put into my cart. And how do I want it to turn out in this problem? Well, I'm looking for the probability they're both defective, right? So first DVD player, and I'll say is defective. Is defective. Okay, so that's my first probability. The probability the first player is defective. So then the question is, what is that probability? What's the probability the first player is defective? Well, we'll figure that out in a moment. What is this one going to be? This space is going to be the probability that what you would say, obviously, it's the second DVD, right, player? So second DVD player. And what do we want to have happen here? Well, we want it to be defective, right? So second DVD player is defective, right? But when we go to write out the probabilities here, I'm going to do something a little different. I'm going to do the number of over total for both of these in detail. So number of over total, right? Because remember, the basic fraction of probability is just basic probability. So when we're at the single fraction level, it's just basic probability, and it should be number of over total. Well, I'm going to do that for both of them this time. Sometimes we skip past this because we've done it so many times, but here we want to be very careful and do it separately. So here we're going to say the number of, what is this looking for? It's the number of what? Defective players, right? Number of defective players on the shelf, right, over the total number of players, right? That's what the first probability is. So we could figure that out. If we go to the problem, we can figure out how many defective players on there. It says, if a store has 20 DVD players on a shelf that work perfectly and 3 that are defective, so the number of defective players is 3. What is the total number of players? Don't make the mistake of saying it's 20. A lot of people do that because they think, oh, big number, small number. Small number is the one on top, big number on the bottom. That's not right here, right? Because it actually says there are 20 that work well and 3 that don't work well. Collectively, there are 23 players on the shelf then. So the total number of players on the shelf is actually 23. So you have to be careful there. Sometimes they give it to you as good and bad, and you have to add them together to get the total. Okay, so now that we have that filled in, then we think about the second fraction. You don't want to just jump in here and say, oh, it's 3 over 23, because when you think about this problem, if you're purchasing the DVD players, right, I'm going to pick one up, put it in my cart, and then I'm going to go back to the shelf and get another one. When I go back to the shelf is not the same as it was the first time I went in, right? So before my first selection was made, I had 3 defective players on the shelf, 23 total players on the shelf. After the first selection is made, before I go get to the next DVD player, there's not as many DVD players on the shelf, right? And so clearly it can't be the same fraction of probability. So what I need to write here is this is the number of defective players left on the shelf, right? On the shelf. Over the total number of players left, right? On the shelf. Isn't that the proper wording for this probability? I think so, right? Because what we're saying here is that the number of defective players left on the shelf is no longer what it used to be. And why is that? Because we always assume that the first probability happened the way you wanted it to in the statement here. So you're not going to wonder, well, gee, what if I didn't get a defective player when I went to that shelf the first time? You're going to imagine that that's exactly what happened. So given that that is what happened, that you got a defective player on the first selection, what's the probability that the next time you go to the shelf, you get a second defective player? Well, how many defective players would be left on the shelf after that first player was taken? There would only be 2 defective ones left because one of the defective ones is in your shopping cart, right? And how many total number of players left on the shelf? Only 22 because, again, one of the players is in your shopping cart. And so that's your final answer there. 3 times 2 obviously gives you 6, and then 23 times 22, that's 400 plus another 100, that's 500. I think it's 506. Let me just double check that with my calculator. So we have 23 times 22, and yes, that's 506. So 6 divided by 506, it gives me approximately 0.0119. So about 1.19% is my probability. So not a very high percent chance that that would happen to you if there's indeed 23 players on the shelf, of which 3 are defective. Then it would be unlikely for you to grab 2 players and get 2 defective players. That would be pretty unlucky since it's only about a 1% chance that that would occur.